In this video, I'll show you how to solve the ALEKS problem called calculating specific heat capacity. So this problem is giving us all the data that we need to do a specific heat capacity calculation. And I think the trickiest part of this problem is just getting all of your variables in the right spot while you're doing the calculation. One of the hints that we have in this problem is that the units of specific heat capacity are provided to us. Those units are joules times gram to the -1 times Kelvin to the -1. ALEKS writes them a little bit funky. I think it's easier if we think about it like this. So these units really give us information about how to set the problem up, or how to set the variables up to give us the correct value for specific heat capacity. So on the top of our calculation, the first thing that we need up here is the heat in units of joules. So this is where I'm going to make a note here. This is our heat. And in this problem, I have 15 kilojoules of heat. I do need to convert that from kilojoules into joules. So that's going to be 15 times 10 to the 3 joules. And I'll go ahead and do that conversion down here. 15 kilojoules converted into joules looks like this. 15 times 10 to the 3 joules. Now, in the bottom part of our equation here, we have the mass of our sample or our object. It needs to be in units of grams. And my object mass is 526 grams. The units are correct, so I don't need to do any kind of conversion there. 526 grams. And then last but not least, we have, so I'll make a note, that's our mass. Last but not least, we have Kelvin. This represents the change in temperature. So this is not looking for a temperature, one single temperature. It's actually looking for a change in temperature. With these problems, the object is being heated up. And so in this part of the problem, we are inputting the change in temperature. Now, one of the funky things about Celsius and Kelvin is that the change in temperature in units of Kelvin is going to be exactly the same as the change in temperature in units of degrees C. This is because the increments in the Kelvin scale are exactly the same as the increments in the Celsius scale. You could verify that for yourself if you want. I'm not going to go into that kind of magic. It's actually not very magical at all. But you'll notice in this problem, if we go look at the temperatures that have been given to me, here are my temperatures. ALEKS is giving you those temperatures in degrees C. In this problem, it does want the temperature in Kelvin, but you do not have to do a unit conversion, a Celsius to Kelvin unit conversion. It is absolutely not necessary because, again, what we are looking for here is the change in temperature, the high temperature minus the low temperature, which is 11.7 degrees Celsius, which is also going to be 11.7 Kelvin. And if you don't believe me, you can convert this to Kelvin. You can convert this to Kelvin. You can take the difference of them, and you're going to see that it is 11.7. So you don't need to do any unit conversions with the temperature unless it happens to be in Fahrenheit. You can just take the difference, and that is going to be it's going to work for Kelvin, 11.7 Kelvin. And this is all that we need to solve this problem. 15 times 10 to the 3rd divided by 526 times 11.7 gives me a heat capacity to 3 significant figures of 2.44 joules per gram Kelvin.